Namaste, welcome to this course on consciousness of the built environment. This is a two-day course offered by Dr. Satyajit Ghosh through the Gnostic Center, International Center for Integral Studies. And it is specially offered as part of a new initiative, Sri Aurobindo Integral Education Network, which is quite a unique endeavor of various centers dedicated to Sri Aurobindo all around the world coming together to form a network as a tribute to Sri Aurobindo in his 150th year. So this is almost one of the second courses in this endeavor. So I welcome all of you on behalf of Gnostic Center and of SAIEN, the network. I would like to just briefly introduce Dr. Ghosh before I hand the proceedings over to him. Dr. Ghosh is currently a senior professor at the School of Mechanical Engineering, Vellore Institute of Technology. He's also a visiting professor at the School of Earth and Environment, University of Leeds, UK. Formerly, he has been a research associate at University of Cambridge, UK, in the Department of Applied Mathematics and Theoretical Physics, and also University of Manchester, Institute of Science and Technology. His research areas include aerosol cloud interactions in mixed domains, analytical quantifications of received green amounts, cloud autoconversion and accretion processes, non-ideal aerosol signatures on cloud conversion processes, and more recently, biometeorological applications over the built environment. He has received the Editor's Award from the Royal Meteorological Society UK for enthusing young Indians to engage with meteorology. And I can see so many young Indians in this course as a proof. He's an associate editor of the journal Atmospheric Science Letters and is also a fellow of the Royal Meteorological Society. He has over 75 peer-reviewed international journal publications, and he has authored many books, including books published by Macmillan Education and Routledge. Dr. Ghosh has been personally mentored by Anuradha that is, at the Sri Aurobindo Ashram, Pondicherry. So Dr. Ghosh, welcome, and please, we are looking forward to your beginning.
First of all, I wish to thank the Gnostic Center and especially Amita and Anuradha. The connection happened in Anuradha's room just opposite the Samadhi, and I don't think there could have been a better setting for us to be introduced to this wonderful initiative that the Gnostic Center is undertaking. But I would also like to thank my very dear student, Mr. Siddharth Gumbar, who has helped me put together this lecture series. The preparation took over 3 weeks to do, and it was Siddharth's help that made this possible. I wish to thank every one of you who have joined, and a little bit about the flavor. I have not used a single equation in this presentation and have diversified the context so that it should apply to people of many disciplines, not just engineers and mathematicians. So without much ado, I shall start my presentation. This one. Can you see the screen? Hello? Yes. Anuradha, is the screen visible?
Yes, Dr. Ghosh.
Yes, thank you. So what you see on the screen is a unique landscape. You can see half of the landscape covered with clouds, and these are cumulus clouds, white, fluffy clouds, adding texture to the environment over the savanna grasslands, punctuated by acacia trees. And on the left, you see a manyata, an African house, a traditional house entirely built out of uh, fabric that is completely sustainable. This is just to illustrate that, and it has a roof that is completely sustainable. So what a perfect picture it makes, the landscape. There's nothing jarring in the landscape. So we shall be talking about what makes a landscape beautiful, and objects placed within the landscape are essentially human beings and a lot of other buildings. So you know about the course contents, this was circulated, but I shall be touching about environmental consciousness. In the light of Sri Aurobindo and the mother, it'll become quite clear that what special beings they were and how farsighted were they in their vision. And then I'll work through several case studies. Here I wish to thank my students who have helped develop these case studies over the built environment. And we shall be largely talking about the ethos behind climate sensitive architecture. So the first quotation, architecture is inhabited sculpture. And this is by Constantin Brancusi. And I saw a Brancusi sculpture the first time at the Kettle's Yard Gallery at Cambridge. And a Brancusi sculpted head was placed on top of a grand piano. The ethos was behind this Kettle's Yard Gallery. An exhibition space is meant to be experienced quite personally. And you were meant to touch the sculpture, you were meant to feel everything and to find the artwork's association with everything around it. And of course, there are people. So I think this is quite an apt quotation that architecture is indeed inhabited, emphasis on the word inhabited. Obviously, they're inhabited by human beings who are conscious and sentient. So a little bit of connection, that connection between architecture and literature, especially poetry, because Sri Aurobindo was a poet, not just a freedom fighter and a sage. So the immediate connections are we walk through places, in inhabited places, and we also walk through poems. And there is a connection between buildings and poetry. So what are these connections? When one discusses poetry, one builds up on structure, proportion, rhythm, and balance. And I'll give examples, a lot of that from Sri Aurobindo's poetry. And there are set techniques to express depth and vastness, warmth, coolth, comfort in both these forms. And one explores balance and areas of contrast, as well as areas of harmony in poetry and in the built environment. And importantly, both are entirely human-centric. So what this tells us, poetry is written to express moods and feelings, and buildings are built to evoke feelings as well. So I'm going to start off this session with a very short bandish done by one of my students, Mr. Vishnuvardhan, who specially did this for this particular course. I'll show his research work as well, the work that we did together on the Delphi amphitheater. Vishnu has just been admitted to do a PhD in the built environment at Loughborough University. So thank you, Vishnu, for giving us this beautiful piece. I want you to be aware of, this is a piece that is invoking the sense of the monsoon and the yearning that happens between lovelorn people enclosed inside a palace waiting for the rains to happen. So there are twists and turns in the way the music flows out, just as there are twists and turns in proportion and rhythm in the structure of a poem, in music, as in buildings. So over to Vishnu's wonderful rendition.
बरखा बहार आए बरखा बहार आई सब जन गाओ बरखा बहार आई सब जन गाओ बरखा बाहर आई.
So you saw that beautiful rendition in unaccompanied voice by Vishnu. Now
Thank you.
over to the poetry of Sri Aurobindo. Many of us at the Gnostic Center, we have had the privilege of interacting with poets directly in the ashram. I certainly had the privilege of interacting with Anuradha, who was a wonderful poet, and also Amal Kiran and Shahanadi. Why I make a reference to Shahanadi, Anuradha introduced me to Shahanadi, and she told me that how specific moods are accentuated by making certain structural changes. She gave an example that when Rabindranath composed Nrittiru Tale Tale, it had one tala all through the 4 stanzas. It was Shahanadi who said, change it to 4 different talas to express different moods. This is very reminiscent of the changes that we have to make in the way we build our cities so that they conform to our expectations, keeping the aesthetic dimension in mind. With that background, we will see how the Sri Aurobindo Ashram and the Sri Aurobindo movement is motivated to perform their everyday activities, including the spaces they live in. Here is an example from Book 4, the Book of Birth and Quest, from Sri Aurobindo's epic poem, Savitri. Those of you are new, Savitri is considered one of the longest poems in English literature. And it is epic proportion and epic dimension, and it is written in blank verse. As I was preparing for this lecture series, I looked for passages. I counted the number of times buildings and the environment was used, several tens of times. And these particular lines from the Book of Birth and Quest: the palace woke to its own emptiness. The sovereign of its daily joys was far. Her moonbeam feet tinged not the lucent floors. The beauty and divinity were gone. Delight had fled to search the spacious world. The wistful longing in Vishnu's, singing that perhaps delight has fled and the rains will bring them back. And then, of course, there are descriptions of palaces, King Ashwapati's palace, to the winds and Madra flowering up in delicate stone. Clearly, stone is a cladding material in many buildings. We shall study a lot of that in this course. And then in the Book of Yoga, much more evocative. At first, to her beneath the sapphire heavens, the sylvan solitude was a gorgeous dream, an altar of the summer's splendor and fire, a sky-topped flower-hung palace of the gods, and all its scenes a smile on rapture's lips, and all its voices bards of happiness. There was a chanting in the casual wind. There was a glory in the least sunbeam. Now the last 2 lines, chanting in the casual wind, perhaps alludes to the way the wind gushes and meanders through the built environment, sometimes slothfully and sometimes in terrifying proportions, as in cyclones. And the least sunbeam perhaps alludes to the play of shade and light, and the delicacy of interior diffuse radiation inside the built environment. So over to the first case study. So this relates to Anuradhapura, which is located in the north central province of Sri Lanka. And we went to a SAARC summit in Sri Lanka to study the built environment in Anuradhapura. And my students who did this, Akash, Goenka, and Tushar, they helped me do this. So Anuradhapura is an entire city declared as a UNESCO World Heritage Site, and it remains sustainable for 1,000 years, in the sense it never used artificial energy. And it was functional from the 4th century BC onwards. And the picture on the bottom right, you can see some of the building fabric. I'll repeat this again and again. In technical parlance, we say the building fabric, where we refer to the stone, the brickwork, everything that the building is draped with. You can see a combination of bricks as well as sculpted stone. So an overview of the region we are talking about. This is an ancient map of Anuradhapura. I shall introduce you to the Sinhalese terms. On the bottom left, you have the Tissa Weva. Now, Weva means a tank or a lake in Sinhalese, and Tissa was a king, and so the lake is named after him. And there's another word that is visible on this map. It's called the Dagoba. Dagoba in Sinhalese means a stupa or a shrine. We shall study 2 of them here in quite great details. And then you see a crisscrossing of the roads that are laid out. So what you see is dispersed, exposed bodies of water, lifted areas, dormitories, as well as reliquaries and stupas. So this is a picture of Ashoka, and perhaps not many of you know that he first sowed the seed of sustainability around the built environments. For the first time ever, he was a Mauryan king, and it was Ashoka's son and daughter who, after the Buddha's death, his remains, particularly his collarbone, was actually taken to Anuradhapura and enshrined in a magnificent stupa. And why he's relevant to our course, he was extremely conscious about sustainability. So I shall show you a photograph of an Ashokan edict. You know, edicts are decrees that are etched in stone for posterity so that they do not weather. So this is an Ashokan edict, and take your time to read it. So I'll stop my narration for 30 seconds. So let's read the edict, the translation of the edict. All right. So perhaps not many of you know that it was Ashoka who introduced the concept of avenue trees, certainly in this part of the world. And along the roads, I've had wells dug and trees planted for the benefit of humans and animals. And the preceding lines, he's also talking about having plants imported from elsewhere to have them grown. So you can see that how environmentally conscious he was. So a little bit, the roots of sustainability of, when we are trying to build our smart cities, the aim is to use the least amount of energy and yet make the occupants as comfortable as possible. And clearly in a sun-drenched country, a peninsular country, which receives a lot of fresh air and land and sea breeze, ventilation is of prime importance. So we shall be discussing tenets of ventilation, two forms of ventilation. I shall explain very clearly and slowly. So on the left, we see a room and we have a heat source in the form of a computer. So computers generate heat and it releases a buoyant plume, buoyant because it rises upwards. And there is an aperture at the top right. So from that aperture, when the hot air rises, some of it flows out, and then you have cooler environmental air coming in. So after some time, the entire space within the room get mixed up and a uniformity is established eventually vis-a-vis the strength of the circulating wind and the temperature. This is called mixed ventilation. And in contrast, if you have two apertures, one at the bottom, one at the top, something quite manageable happens. So again, you have a buoyant heat source, the hot air rises and escapes from the top, whereas you have an onrush of incoming cold air from the bottom aperture. So what separates the two systems of air movement is a neutral layer. This is marked by that line. So on the top, you have light and warm air, which is flushed out. And at the bottom, you have cold and dense air. Now, this is called displacement ventilation. What architects like and what is good practice is to have displacement ventilation within a room. This is more manageable because you have a handle on the height at which the neutral air is positioned. Literally, if you have your head in hot air, you're uncomfortable. So architects design so that the neutral air is way above your head and you're always comfortable. So we shall see the patterns of ventilation in this ancient city of Anuradhapura and explore how did they ventilate its lived-in spaces. So here you can see typical, these are my photographs about the bricks. And you can see they're much larger than conventional bricks. And then you have the stonework. And on the right, you have several exposed water bodies, which is not just meant for irrigation, but for other purposes also. And the Asuka Edict alluded to the importing of trees. And this is a survey, this is a geographical prelude. Mind you, Anuradhapura, the latitude is 8 degrees. It's still in the northern hemisphere. And we in Vellore are about 11 to 12 degrees, not too far away. And so the type of trees that you have native timber trees and multipurpose trees and fruit growing trees, just like as in South India. This is called a windrose. I shall explain that quite clearly. These concentric circles refer to the wind velocity. So 10 kilometers and 20, 30, 40, and so on. And the north-south directions are marked. And this legend tells you the number of hours the winds blow over to the receptor, which is the center of these concentric circles. So if you have a very dark shade of blue, the wind speed has been less than 20. The wind has blown at that speed, which is about 10 kilometers per hour for less than 20 hours. So even a casual look tells us the wind is actually blowing from the southwest to the northeast. So that is the receptor point. And why is that so? This is an average for the month of September, when the northeast monsoon winds are just about to develop. So scientists use a windrose to find out the dominant patterns of wind flow over a region so that they can place their doors and windows suitably to tap into the ingress of external wind. So we shall be studying a skyscraper. This is called the Great Brazen Monastery. And this was arguably the first skyscraper in the world, built in 100 BC. It was 9-storied high and 9 residential halls with meditation rooms. And it's brazen because it had a brass roof. This is again my photograph. You can see 1,000 granite pillars. These are remnants of the actual structure. And then you have built up a sort of walkways for the lived-in dormitories, some of them, and they used proportionate architecture, 61 by 61 by 6. Perhaps it has a Buddhist significance, and it was clad in wood and copper. So now I shall introduce something called as computational fluid dynamics. This is or CFD, building physics and computers have evolved in such a way that we can recreate an entire city on our computer workstations. And this is an example of the recreation of our brazen monastery, 9-storied high. And we gave it a copper roof, which was pitched as in the original. And when we place it into our portal, it tells us vis-a-vis the position of the sun, what parts of the skyscraper are lit and what are in the shade. And if you remember in the beginning, I had said, you know, in poetry, we have regions of contrast. So here is an example, regions of contrast in the built environment, only the tools are different. So this gives the architect a foreknowledge of what parts of the room at what time of the day and what month of the year are going to be most comfortable. So that is for the Great Brazen Monastery. And there was another building that we studied. It's called the Jetavana Vihara. Vihara is a monastery. And like most monasteries, the Ratnagiri Monastery in Orissa, and this is the Anuradhapura Monastery. It has a quadrangular structure. And I was quite intrigued that when I lived in Cambridge, all the old Cambridge colleges, Trinity and King's, where Sri Aurobindo studied, St. John's, all of them had this quadrangular structure in the lived-in areas. There was a central quadrangle with lived-in areas around it. And here there's a main archway. So there is a constriction at the point of entry of the wind, and the wind rushes in at high speed and fills this quadrangular space, which aerates the rooms. And you can move around, you can move your sun position around to see which parts of the rooms are sunny and which are in the shade. So the Jetavana Vihara was constructed using brick and stone. And this is again an application of the computational fluid dynamics related to the study of ventilation patterns. I'm going to take some time to explain this. The wind flow direction, this is a plan view of the Brazen Monastery. It had a square plan, and this is the direction of the wind flow. It is blowing from this direction to this direction, and these apertures are the doors and windows. So the greens refer to wind velocities that are moderate, and the blues refer to wind velocities that are virtually still. So this is about 0.3 meters per second. So what you see is regions of high flowing wind is actually exterior to the main structure, your lived-in area. And we see a streaming in of slightly high-speed wind velocities, and the regions of low velocity wind is juxtaposed alternatively between regions of high velocity winds. Now that is a good thing. So if there's a gradient in velocity, that actually fosters better flow even at low velocities. So you can see one large eddy with quite low velocity that is filling the entire structure, but that is placed next to region of high wind velocity. So this gradient is making the room well aerated. You also see regions of high velocity over regions where there are sharp edges. Now, sharp edges cause turbulence, and these can be disruptive. So some of the buildings in Auroville, those of you who've been there, are contoured. Fishermen's huts in coastal districts of Andhra Pradesh and Orissa are contoured, made round so that the wind can meander along the sides without experiencing a lot of gustiness. So in summary, if we do a computational fluid dynamical study based on the plan and the original structure in a downscale model, we get a feel for what might be the actual patterns of ventilation. So I would like you to pay your attention to the graph on the right. This is a very important concept. So on the y-axis, we have the temperature in degrees Celsius. And on the x-axis, we have the time of the day. We are concentrating of a 24-hour period. And we are looking at two categories of buildings, a lightweight building and a heavyweight building. Heavyweight building in blue and the lightweight building in red. And the green line refers to the external ambient. What is the temperature outside the building externally? So let's look at the external ambient curve. So that's what it looks like. It's cool in the mornings as the sun rises up. The temperature increases rapidly. It's extremely hot at about 2 p.m. And then when the sun proceeds to set, you get cooler evenings. So that's the profile of the ambient. Now let us look, how is a lightweight building coping with that pattern of ambient temperature variation? So the lightweight building in red, you can see that for most part of the morning up to lunchtime, it's actually hotter than the exterior. A building is supposed to regulate indoor temperatures. Instead, it has absorbed all the excessive heat from outside, and it's making you bake like an oven. And for a lightweight building, it is always warmer than the outside. It's better to step out to feel comfortable than stay indoors. But in contrast, if you have a heavyweight building, you use a lot of stone, which is heavy, and then you can see that although it has been warm up to mid-morning, but come late afternoon, you can see that the temperatures are actually lower than the ambient at the hottest time of the day. And you might wonder, is 2 degrees centigrade going to matter a lot? It matters profoundly, particularly in the way we have our air conditioning sets. I'll talk about that later. People are talking about adaptive thermal comfort. What is comfortable to an Icelander? An air conditioning setting of 21 degrees centigrade in New Delhi would be comfortable, but it would be Arctic weather for someone from Anuradhapura. So even a few degrees matters with respect to the amount of energy you conceive. So the summary of that takeaway is, in hot climate, we should play around with patterns of ventilations and adjust our ceiling heights so that we foster displacement ventilation. So we have 2 manageable layers where we can position our doors and windows, and it acts as a better climate regulator. So again, with the application of computational fluid dynamics, where we were able to establish the expected temperatures for a cold month and a hot month quite accurately for the 9-storied ancient skyscraper. So this is a reconstruction, and we found that both the mornings and the nights were comfortable, even though they used lightweight material. But the building was roofed with copper. That would have made the upper floors extremely hot. So what it is anticipated that the monks would have to modulate the activity, so that move between floors. So you can see that the staircases are exposed to the elements, and you do not have covered staircases. So I'm going to go slightly deeper into the technicalities of ventilation. Because if you have good ventilation, you do not have to turn on your fans. So what you see on the extreme left is the ambient wind profile. So there are arrows. The arrows indicate that the wind is increasing logarithmically with height. It is almost zero as it touches the ground. There's an obstacle. And then as you go up, it's increasing. I'll give a very simple example. So when we were little, me and my sister would fly kites, and often the kite wouldn't take off at the ground level. Then our father told us, take your kite up to the 2nd floor of the roof and release it from there. And lo and behold, the kite took off. Why was that? Because logarithmically the wind increased at the 2nd floor. It had a reasonable wind speed for the kite to lift off. So when we have a strong mean wind that is impacting a building, several things can happen depending on how strong the wind is. It can bifurcate and move around the building, or it can move over the building depending on how strong the wind is and how big the obstacle is. And you might have something called wakes. Example of a wake is when you see a duck skimming at the surface of a lake, you see a triangular wake as it's propelling forward. And the wind speed generally inside a wake is small. So architects have to bear in mind the patterns of wind flow, regions of low flowing winds in the wakes and streaming flows around and over the roof. This is an example, my photograph, about what the Jetavana Vihara looks like. It has an assortment of trees, which is slowing down the free flow of wind. That is a desirable trait. Perhaps they did not want their butter lamps to be extinguished all the time. So this is again the power of computational fluid dynamics. Satellites pick up the prevailing wind speed. You feed the satellite wind speed onto your portal. I shall play you an animation in the next slide. Mark that the regions of red indicate high wind speeds, and the regions of blues and greens indicate low wind speeds. As I run the simulation over the Brazen Monastery, you will see that the regions of red are preponderantly going upwards and upwards. Now it will soon reach the top of the pitched roof and fill it with a lot of red contours, which is a desirable thing. So this is simply a summary of the seasonal variations of the winds. First intermonsoon season, then they have a southwest monsoon, and then second intermonsoon and a northeast monsoon. And the lowest wind speeds are really low. And here I wish to comment that, in our metropolitan cities, the air quality index is the worst when you have low wind speeds. So winds actually disperse the pollution. And then the highest wind speeds were extremely good values. And these are the notable features. There were vertical wind structures, eddying motions. These were present, fortunately, in all the seasons. And some of the contours are tightly packed. Tightly packed contours indicate that there are velocity gradients, closely spaced velocity gradients that make the winds move even when the speeds are not very high. So this is an overview of the remnants of the ruins of Anuradhapura. And now we are looking at what obtains at the Jetavana Vihara. So my students and I, we reconstructed them. We have clad them in the actual building fabric. And you can see the archway in the front with a quadrangular court, which is letting in the airflow, aerating all the dormitories around it. So the living quarters, we have cells around a quadrangular courtyard. And then a little bit about the bricks. The brick and stone, we measured the specific heat capacities. These are certain values. These are molecular properties, the capacity at which it absorbs heat. And this made it a building of relatively low thermal mass as the Great Brazen Monastery. And so whilst the summers would have been uncomfortable, the winters would have been decently comfortable. So you can see that the size of the bricks are much larger than modern day bricks. Now, from the museum, there were lots of clay objects and the buildings of the Jetavana Vihara. And again, the structural properties were studied, and that included timber and granite and copper. Now I come to another very important concept, slightly dated. This is something called the predicted mean vote. Clearly, the levels of comfort have to be pinned down to a scale. We have scales for everything now, including the ways our journal publications are rated, our educational institutions are rated, our institutions are ranked. So it's not surprising that the levels of comfort have to be ranked in today's world order. So this is a ranking by ASHRAE, American Society of Heating, Refrigeration, and Air Conditioning Engineers. So they devised a 7-point scale based on the mean response of a large group of people. Imagine all the 39 of us are sitting in a lecture theater. So you are asked individually, you have to tell your teacher whether you are hot or cold or just right. So if you take an average of all the 39, and you'll get responses from all the 39 people. And obviously that response would depend on various factors, including your body metabolism. So the PMV index, so if you have an index value between -1 to +1, you're very comfortable. And if you're going to -2s and 3s, you're quite chilly. Likewise, the +2s and +3 are very warm. So we wanted to explore how did the Anuradhapura buildings fare vis-a-vis this American Society of Heating, Refrigeration, Air Conditioning scale. So again, we had to use computational fluid dynamics. So on the left, we placed the 9-storied ancient skyscraper with a copper roof in an environment that proxied quite accurately the positioning of trees, and it returned us the PMV values. So you can see that the PMVs are all extremely, now these are external indices for external thermal comfort, and it was extremely comfortable. I mean, -1 to +1. And for the Jetavana Vihara, it was still again between -1 to +1. So what is this suggesting? That the environment immediately around the places where the monks lived were extremely comfortable. And this was done through computational fluid dynamics. So this is, again, I won't play this again, it's repetitive. We can do a pattern of the wind flow inside that building. So again, a summary of the Great Brazen Monastery, and we're looking at the PMV values. They're all between, it's never hot, it's rather on the cool side for both the important structures. Now we come to another form. This is a kind of a lived-in environment where monks study and work. Now, what is the center point of this institution? Clearly, the center point is the shrines where the Buddha's relics were brought over. Just as our center point in Sri Aurobindo ashram is the Samadhi of the Mother in Sri Aurobindo, the courtyard. Every religion has its center point. So here, the relics of Gautama Buddha had to be enshrined very carefully in a grandiose manner to be an object of veneration for thousands of years. So what you see here is a plan view. It's a circular form, and the 5 major elements of a Sri Lankan stupa. It has a cylindrical base, and then you have a relic chamber at the center. Over that you have a dome. Over that you have a square turret and a conical spire. So I'll show you a picture of this is the Ruan Valley Stupa. It was refurbished and painted and landscaped. So that is what you see. The dome was initially built to a height of 73 meters, and now it stands at 103 meters, and it's the tallest stupa in Sri Lanka. And the shape was a perfect hemisphere originally. But as we shall show you, stresses developed by that shape and it had to be changed. And then you have the second stupa, the Jetavana stupa. This is not hemispherical, but it's like a paddy heap. Perhaps this is why you have the word Dhanya Kataka, that a heap of paddy, that should be the most defining shape of a Buddhist stupa, but you have the turret and the spire. So this is another shape. And in its time, it rose to a staggering height of 122 meters and was the 3rd tallest brick structure in the world, closely following the pyramids of Giza in Egypt. So let's have a picture of before that. Okay. So when I talked to the people, we understood that Buddha's collarbone was enclosed in several layers of building fabric. And in Kandy, the Buddha's tooth relic, again, there are several layers of boxes, starting with gold foil and silver foil and rosewood. Perhaps it has a connotation of, the permeability of different layers of our consciousness. So the reason why they had to do it like that. And the mother was very familiar with tenets of Buddhism, and Dr. Nirodbaran, who mentored some of us, had Buddhist origins. So the mother allowed, after Sri Aurobindo's passing away, some of his mortal remains, his nail and hair, they were relics. So she allowed the relics to be taken out of Pondicherry to be specially enclosed. Now, I would really be very grateful if Amita uh, takes over for a couple of minutes to say what are the points of differences between the modes of enshrinement of the Buddha's relics, as we just saw, and the way the relics were enshrined at the Gnostic Center in particular, and how how did it all come about, and what was the form in which the relics were actually embedded. So Amita, I shall be most grateful if you turn on your video and we can see you.
Sure. Um, well, I don't know so much about this subject, but I can just share with you what we were told and what I learned when the relics had to come to the Gnostic Center. Obviously, as you know, that they were encased in different small boxes, and that those may be the different sheets. So there was a rosewood box, there was a silver and a gold box, and so on. So one, of course, the actual relics, were the hair or the nail of Sri Aurobindo, and then these were put into different casements. And once these boxes we were just handed over this one box which had obviously within it all these other boxes, and we were asked to carry it to the Gnostic Center, and of course we had a very special preparation for the shrine and the place where we were going to enshrine that box with the relics. Strangely enough, there was an occult, what should I say, formation that the mother wanted 12 people to carry the relics. And in our case, there were 12 strange, we didn't know that, at least I didn't know that at the time. But there were 12 of us that actually carried the relics from Pondicherry Ashram to Delhi. Amongst them was Chumurdi and Nath Karniji, some people from Auroville, and a few of us from the Gnostic Center. There was Dolly Di, there was Preeti Di, so there was some really, really Gauri Di, Dev Di, Matri Bhai, so on. So later I found out it was exactly 12, and that's what the mother wanted. We went, and then what we did was that there was obviously the shrine itself. The mother wanted that the shrine should not be so much like a grave, but should be something like more an aerodynamic sort of form. So that's why she had drawn it for the Sri Aurobindo Ashram Delhi branch, which was like a conical shape, very similar to the stupa that you show here. And if you see the photograph of the Delhi Ashram place where the relics were enshrined, Taradi told me later that the mother had drawn it in great detail with the lotus petals and this conical shape and the pointing spire like this, so that the energy went up. So similarly, we had like a Shiva kind of thing. It was an oval shaped thing. We had the 412 rays of the supramental sun that were, it was like a mirror image on the roof and on this marble, a white stone that we got. And in the center of that, we put the relics inside a kind of a space that was created to fit the box in exactly in the center of the stone. And then this was covered back with another stone piece that fitted perfectly there. And then on top of that, we put the symbol of Sri Aurobindo. So that's how the relics were enshrined.
Thank you so much. That's the kind of rounds off so wonderfully. Thank you so much for that. I'll proceed with the rest of my presentation. So a little bit about scientific research. We're comparing the building fabric of the Ruwanveli Stupa, the Jetavana Stupa, and compared to modern day restoration work. So you can see that the length of the bricks are over double the size of modern day bricks, and they're thicker and wider, and the densities are comparable. and the Young's modulus. So these are sort of material properties that tells you to what extent a brick would be sheared by the application of external force. So now we are trying to see what does the self weight? This is a massive structure. It has a weight. Now, what is that weight going to do at the foundation? So again, we looked at the stresses, and you can see here that there is a predominantly greenish hue, so that there are not tremendous gradations of the stresses even at the bottom. But contrast this to this perfect hemispherical shape of the original stupa. There's a stark contrast. You have the dark blues at the top, and you have a different shade at the bottom, indicating there are sharp gradients between the stresses. Perhaps that cause the stress marks at the bottom, which had to be ameliorated subsequently. So a little bit about riparian architecture. The Indian newspapers are awash about riparian disputes between neighboring states, certainly between Tamil Nadu and Karnataka, about the sharing of water. So riparian refers to management of water resources, and you can see the region where we are talking about. And we used, so Anuradhapura receives limited rainfall, mostly during the northeast monsoon season, just like Tamil Nadu. The major monsoon season is not the southwest monsoon. In tomorrow's lecture, we shall get into the nitty-gritty on how it falls and how it is created, how it drizzles and how it lashes, and at how it has shaped civilizations. So today's talk is not focused on the showers of grace. So the point to remember is they receive rainwater from the northeast monsoon, and we got in touch with a sister organization of NASA, a National Oceanic and Atmospheric Administration, NOAA, and they gave us permission to use their code offline. We were the first group in India to do it offline on laptops. A huge, big climate model was run by VIT undergraduate students. This is the Weather Research and Forecasting Model. And that told us, it picks up satellite data of wind speed, humidity levels, all the meteorological variables, and the equations are advanced over space and time to tell you exactly the extent of precipitation over a particular region. Then we found that out that over Anuradhapura, it's a few millimeters per hour. That's not a great deal. So in order to overcome Anuradha's rather low seasonal rainfall, the rulers began constructing large reservoirs and expanding small natural lakes. This was not for cultivation. There's another very important engineering principle that operates. I'll come to that in a bit. So the Basavakullam Veva is a lake. It was quite big. And these shallow yet expansive lakes collected rainwater. And also, they did something quite significant. It chilled the environment. So it is believed that Anuradhians, these ancient residents of Anuradhapura, they invented the concept of hydraulic air conditioning. So if you have shallow pools of water and if a hot wind's blowing over it, your lived-in areas would be fanned with chilled air. So an overview of the plan view, you can see the Ruwan Valley Stupa and the Jetavana Stupa and the lakes. You can see and a massive lake, the Noavara Veva. It is visible even as we were going along the bus. It never left us. And there's an intricate network of canals used to irrigate the paddy fields, and the water was made to flow sometimes through underground channels and sometimes through ornate baths. I shall play a video now to highlight what I've been talking about. This is our creation. This is the sacred bo tree that came from Bodh Gaya to Anuradhapura. This is the Brazen Monastery, the skyscraper which we recreated, and then the stupas. This is just to show you the spatial positioning of these main structures, and then the interiors. You get a view of the stupas, the holiest of the holy from where you live in, and you can place trees. You can see the stresses with that shape at the bottom. It's crumbling at the base. Now the Jetavana Vihara. And this is starting with the end opposite to the gateway. So a summary that water from these tanks were siphoned off for use in dormitories and also cultivation. And the villages were concentrated around regions where you had reservoirs, and houses stood immediately below the reservoir so that you had easy access to water. And this facilitated fruit and vegetable cultivation. So this is a SketchUp reconstruction of a subterranean conduit which carried water from another lake, the Tissa Waiver, to the Great Brazen Monastery. And another video that my students and I created. Clouds from the northeast monsoon, the Dwara Waiver, the blue stupas. a summary. All the major structures were spaced out with standard norms of city laying. In tomorrow's lecture, we'll see how the Indus Valley civilization, how their city grids compare to us. And a kind microclimate fostered very comfortable outdoors with gently caressing winds that lended high levels of comfort. And so they used a combination of building fabric, brick and stone and granite and mortar. So in technical parlance, if you have composite layers, the ingress of heat from layer to layer is slightly convoluted, and so your interiors are more comfortable. So now the shapes, the Jetavana Super's near perfect elliptical shape was a marked improvement over its hemispherical counterpart. Look at the engineering genius that they displayed. So to wrap this up, I would like to quote some lines from Sri Aurobindo. This is what came to my mind as I was looking for lines within Savitri. Far wandering seekers on the eternal's path. So these Buddhist monks were certainly far wandering seekers, brought to these quiet founts their spirit's thirst. So the Jetavana Vihara premises are verdant and empty, very spaced out and quiet, and spent the treasure of a silent hour. Clearly, the brazen monastery with its 9 floors were meant to have several silent hours in contemplative meditation, bathed in the beauty of the mild gaze that uninsistent ruled them from its peace, and by its influence found the way calm. So those of you wish to, this isn't hyper, is it? No. Yes. Yes. So this is shared. This is a published piece of work. This was published in Artificial Intelligence and Society, a Cambridge journal, and where people who have registered this course have free access to this paper. I'll just show you the sections on, this is where we talk about landscaping in Anuradhapura, and what I just showed you in this PPT is there in this paper. And we talk about everything that I just presented, including riparian architecture. Very sound. I can just close this. So now we come to India, not too far away. This is a very recent study. This is Arettipura in the Mandya district of Karnataka. And this was done by Siddharth, whom you just met, who's sitting by me, and 2 identical twins, Sagar and Samir. When they started this work, they were hardly 20. And they shot to international fame with the publication of a paper and now they are working on artificial intelligence at the Carnegie Mellon University. So they are the co-authors of this paper. Again, registrants from this, yes or no? Yeah. Have free access to this peer-reviewed publication in an American journal, International Journal of Biometeorology. So it's called Engineered Bioclimatic Responses in Ancient Cities. It's quite easy to understand, but I'll explain this more lucidly. So Arettipura was, unlike Anuradhapura, which is a Buddhist settlement, this is a Jain. The Mahavira and the Buddha were almost contemporaries. And you can see a seated Mahavira. These are our own pictures. And again, you can see mixed cladding, use of stones as well as bricks together. And like Anuradhapura, it was quite rain-starved. And you can see the ruins of Arettipura. You can see the bricks and the stone. And this is in a very lean district, much more dry than Anuradhapura. And we looked at Mandya districts from 1991 to 2018. And we did an annual drought analysis. And we found that 2015, 16, 17, and 18, deviation from the normal was sometimes quite high, up to 34% deficit. So this is the region. So again, a lean region, rainwater scarcity, and again, you need special quarters for habitation to do intense work that required concentration. So when this result was published, the world media took a great deal of notice, especially the British media. And you know how journalists function, they sensationalize stories. When Britain was under the grip of a massive heat wave, the front page of the new scientists said early air conditioning. And when it was published, they're saying that early form of air conditioning kept Indian temple cool. And we had a barrage of tweets of all kinds. But this is the response that this study evoked. So why were the press and media so interested? Clearly, they were in the grip of a massive heat wave, as was our country. So what is unique to this settlement is a unique hilltop settlement. Earlier, I had talked about the logarithmic wind profile and why kites took off when you went up the higher floors. So the winds were stronger. This was a hillside settlement. And what was unique, its pièce de résistance is a granite skirted reservoir. This is our own picture. And what is so wonderful is they skirted it with granite so that the collected rainwater wouldn't seep into the soil. It got retained, but it was beautifully sculpted along the edges. This is lending an aesthetic dimension. And just like in Anuradhapura, the Tissa waiver, the Nuavara waiver, this man-made structure, that's why engineered bioclimatic responses, it promoted hydraulic air conditioning. So when copious winds were blowing over and it's a rain-fed reservoir, it chilled open plan temples and courtyards. And mind you, I wish to point out that it was very difficult to actually measure the dimensions of the tank. It would have been quite easy if we had an aerial photograph, but this was a protected area. Low-lying aircrafts and drones are completely banned, and a clear satellite image was not available. So the challenges were acquiring an image from the top, pre-processing, and which requires technique of histogram equalization. I'll talk about it. And stretching. Stretching means, so you have to delineate the blurred edges from the sharp. This was invented by my very bright students who are now at the Carnegie Mellon University, Sagar and Samir, along with Siddharth. And I'll come to their work in a minute. And we established the dimensions quite accurately. So what you see is the blurred image from Google Earth. And the whole idea is, if you say drain an area with a bucket full of water, it'll drain along natural gradients. So therefore it's called a watershed. So instance, if it's sort of impinging the whole area with a certain kind of light, the light intensity is drained into certain structures. And you can see that from a satellite image, from an RGB scale, we go to a gray scale, and then we create a very sharp black and white image, doing a very meticulous, tedious calculations and histograms. We were able to mathematically configure the exact dimensions that is required to find out to what extent rainwater can be stored in this reservoir. Now, again, coming back to the American Society of Heating, Refrigeration and Air Conditioning, comfort indices. What was shown on a 7-point scale was actually devised by Fanger. And clearly, it relates to the type of activity that sort of if you're running, your metabolic rate is very high. When you're sitting and meditating, your metabolic rate is low. So your sensation of comfort depends not just on meteorological variables, air temperatures, dew point, relative humidity. It also depends on physiological variables. It was Fanger's genius that combined them, and he created a Fanger scale that pertains to a mammal with a 4-chambered heart. So we use the Fanger scales again to re-quantify comfort indices for our large cats, lions, and tigers in Masai Mara, which I shall briefly touch upon. So we went on a field trip and we collected a brick from the site. And what we did in the labs here at VIT, we found out the resistances. What we found, here you can see there's an air gap. And air is an insulating material. And we found that the way the bricks were laid against each other had several air gaps embedded, lowering the thermal transmittivity. In technical parlance, this is called the U value. Architects work with building fabric that have low U value are preferred so that it retards the transmission of outside heat to the interiors. So we first had to establish the thermal transmittivity of a 1,000-year-old brick. And then we recreated the entire settlement. We recreated the 2 temples and the dormitories. And so carefully look at this. So this blue patch is the granite skirted reservoir. T2 is one of the temples. T1, there were 2 Jain temples. And the Ds, the D1, D2, D8 are the 9 monasteries. So what we did, we worked with a CFD code called NVMet, developed in Germany, Daniela Bruce, and we allowed wind to blow from the southwest to the northeast, ensuring that the wind was blowing over the water-filled reservoir so that hydraulic air conditioning prevailed. And we did a baseline case where we did a run by removing all the water. Then we compared the difference in temperatures and we found up to 2 degrees reduction in outdoors temperatures. As I said earlier, that's a massive temperature dependence thermodynamically. And we established the comfort levels applying the concepts of applied mathematics and physics. So in summary, how much time have I got? I have to wind up soon. So we did a brick by brick reconstruction using mathematical and architectural software. A little bit about Indian model of adaptive thermal comfort. The Fanger models over-predict sensation on the warmer side. So we also recalibrated expectations in an Indian setting, those thermal indices. Now, a little bit about how does all this relate to the Government of India's vision on rebuilding our smart cities. So one concept, one takeaway for the dormitories, we calculated the occupancy ratio, the number of people living over a certain given area. So we maintained the occupancy ratio identically and extrapolated our calculations to a modern urban area in Bangalore. So instead of the granite skirted rain-fed reservoir, we looked at exposed swimming pools with the same kind of habitation density. And we found that if we design our gated communities sensibly orient the buildings vis-a-vis the position of your swimming pool, you would actually need much less air conditioning. And this is exactly what was, I had the opportunity to live in some of the dormitories in Auroville and Pondicherry. This is exactly that was done. So now from Sri Lanka to Karnataka, I wish to take you to Greece. Now, Sri Aurobindo studied classics and he knew Greek. He wrote poetry in Greek. So there is a book by Amal Kiran, Sri Aurobindo and Greece. And so you can buy that book. So now let's see what the mother tells about why a building evokes a sense of beauty. You enter a historical building and suddenly you are seized by the sense of a great beauty. How do you explain it? If someone asks you about it, you would say, well, I feel that it is beautiful. But if an architect enters the same building and has the same feeling that it is beautiful, he will immediately tell you it's because the lines meet harmoniously. Remember the first, I said why literature and buildings connect, harmony and contrast. It's because the lines meet harmoniously. The mass of the volumes is in harmony. The entire structure follows certain laws of beauty, order, and rhythm. And he will explain them to you. But that's because he's an architect. And yet you could have felt beauty as much as he without being able to explain it. Well, your feeling for beauty is what Sri Aurobindo calls infrarational, because he can explain with his reason why he finds it beautiful. All this rang very, very true when I visited Delphi. This was a long time ago. And this is the famous site where the Delphic oracles were performed. And the Bandish that you heard in the beginning was sung by this person. And this is one of our papers, again, for the registrants of this course. Yes, you can read it. It is available to you. I shall go over it very briefly. A simulation study of dust transport on ancient amphitheater. So I won't go over it, rather I'll explain what we have done. So on the top, I have preserved an entrance ticket to the Delphi Museum. What you see is a lady with an ancient harp. And this instrument was used in the orchestral settings of a marvelous amphitheater, which we studied. Modern architecture has many instances, a recreation of exemplary Greek art forms. Certainly the Delphi example, it is an exemplary example. And like Anuradhapura, it's listed by the UNESCO. So I would like to play you what that ancient harp sounded like. So that's how do I... So this was an open air amphitheater, 800 to 400 BC, and was the seat of the oracle at the temple of Apollo. And it was a stage for culture, art, and philosophy. And the Pythian game, just like in England, in Chester, we have a repetition of some of Jesus Christ's passion plays, which I happened to visit. So here you have the Pythian games every 4 years, 4 runners of the Olympic Games, which is nearby. And they had a clear sound quality of 60 to 65 decibels, even at the distant row of the amphitheaters. So just as in Anuradhapura, the viharas and the buildings had optimum spacing, even here optimum spacing was adapted, and they used intelligent building fabric, particularly that modulated the transmission of sound, and it ensured thermal comfort for the spectators as well as for the orchestra. And most of the events were held at either dawn or dusk. So this is the original picture, and this is our own architectural reconstruction of the Delphi Theatre using Google SketchUp, and we have sprinkled it with a couple of olive trees which have tremendous significance, as we shall see in a bit. So a likeness with what obtains in reality. A little bit about the formal structure in which these ancient amphitheaters in Greece. So they're semicircular. Then the orchestra here, it held all the performances, the actors and singers and dancers. So you had two entry points just below the cavea. Cavea is this area, and the cunui is the arrangement of seating, and then you are dividing stairs. So the cunui has wedge-shaped areas. So you have an upper cunui and a lower cunui, and sort of going down all the way to the orchestra. So the entries were from either side that led to the cavea. So that divided the spectators. Bottom rows were reserved for dignitaries and the subsequent ones for the common folk. That is the arrangement. So deciphering the dimensions was quite straightforward. We knew the orchestra dimension, the theater height, the slope angle, the cunui angle. And the greater the steepness, the greater overall height, the higher probability of transmission of direct sound from the orchestra to the farthest. So there was an increase in sound attenuation with a minimum loss, and that critically depends on the slope angle and the height to which the seats were released. So again, we did a CFD analysis on the distribution of direct and reflected echoed rays. And we found that even a sound of 60 to 65 decibels reached to the farthest nooks and crannies of the theater. And were the spectators comfortable as they're listening to this beautiful music, particularly in the evenings? Yes, they were. Again, we used the same code, NVMet, and we again wanted to look at the PMV values in the seating areas, and they're quite comfortable at times, slightly on the warmer side. But again, in the evenings, you can see the contrast with the shade and light. It helped us establish the comfort levels in a 2,000-year-old Greek amphitheater. That's why this, and this was published in the International Journal of Cultural Heritage. So the temperatures throughout the cavea was extremely comfortable, and so was the wind insulation. Now coming back to the last theme of this, so how to preserve these ancient monuments. This amphitheater was very prone to soil erosion. So there was an entrainment of acidic ions of sulfates and nitrates, which caused marble cancer and gradual weathering of the structure. But the mountainous landscape enhanced the transmittivity of sound. And there were certain positives and certain negatives. This landscape enriched the sound quality, but erosion corroded and degraded it. So is there a way to stop erosion? Yes. If you carefully plant trees, I showed you the windrows in the beginning. By a detailed study of the prevailing wind flow patterns, you can put in olive trees to intercept wind-laden, dust-laden winds. So we did that reconstruction. We carefully planted grass and trees with a varying height, assorted them suitably, play around with this arrangement to see if these olive trees actually intercepted the dust. and PM10 concentrations. Now, NDTV and all the Indian channels gives a PM10 forecast about pollution levels over Indian cities. This refers to particulate matter 10. PM10 is all particles that have diameters less than 10 microns. So when it's very polluted, the PM10 values shoot up to unacceptable levels. So we did again a baseline study. You find that what was orange without the trees turned to green with the trees, indicating a sharp decrease in the levels of pollution. And again, we looked at the total amount of deposited over 2 weeks, and we've established that with trees, there's less deposition of dust. Now, coming to the very end of this session, so in VIT, we have this kind of summarizes everything that went through. We have one of India's most modern platinum-rated building. It houses the School of Architecture and the School of Design. What you see is a lot of open plan arrangement. This is fostering displacement ventilation with a clear demarcation of the layers of air. And because it's a design studio, light is of primary importance. So it is replete with a lot of passive zones. Now, what are passive zones? Passive zones are zones within a building that do not require artificial forms of energy. So you do not need artificial lighting in the design studios, in the architectural classrooms. You just work with natural daylight and you're filled with comfortable air. But there was an engineering intervention carefully done by this famous architect called Sanjay Mohe. He has chilled running water pipes tucked away between the slabs on the floor. So what happens is, because this displacement ventilation, you have cold, dense air hugging the ground, and that rises. And when hot air generated from the top of a heated roof, so you have mixing of hot air and cold air, and then a neutralizing of excessive heat. The opposite was done in Norway. The first time I experienced heated floors was all the bathrooms in Norway and Sweden. They do just the opposite. So if your feet are warm, you have a sense of warmth and a sense of being comfortable. And here, if your feet are cold, you psychologically you're told that you are comfortable. Again, we looked at the sun path diagrams and did a study on which parts of the building have optimal daylighting. And you can see the interiors of this marvelous building fostering displacement ventilation. So that's the end. So I'll just wrap up in a line or two. So we have seen three main elements: that conservation, managing water resources, the promotion of hydraulic air conditioning to chill our buildings, and the planting of trees, and the building's form, the building's fabric and its alignment, and the way we manage resources. The ancient lived sustainably 2000 years ago in Anuradhapura, then in Arettipura, and the way modern architects are using vernacular idioms to refashion modern buildings. We hope that with this synergy and overarchingly, with an innate sensitivity to things that are beautiful, that are elegant, that fosters a sense of well-being. So the way we, the sentient beings, relate to different tiers of consciousness that appreciates beauty and harmony in all forms of created things, literature, music, painting, and certainly the built environment, then I think with this arrangement of conscious built environment, we become more environmentally conscious people.